All right, we're going to move on to our last section of exponents and logarithms. We're looking at exponential functions as mathematical models. So we are going to kind of use our knowledge and properties of exponential functions and logs to write particular equations. So on your test, there's going to be, I think there's going to be 3 of these. So you'll need to be pretty comfortable with creating those mathematical models. All right, so we're going to use, remember this, y equals ab to the x power, that's our exponential model, to write an equation or to create our own equation. So thinking back to, oh my gosh, when did we do this? Rational functions, writing those rational functions, or writing when we did quadratic functions and we needed points on the graph. That's what we're going to do here. We're going to start with points on the graph, and then we're going to create the equation based on those points on the graph. So here is our punctured tire problem. On your way home from school, you run over a nail. The pressure in the tire decreases exponentially with time since you ran over the nail. After 4 minutes, the tire pressure has dropped from its initial value of 36 psi to 18 psi. So I want to identify my points. And then I'm going to write 2 equations. So that'll be my second step. And then we'll solve for A and then B. Because what we want to do is we want to eventually write an equation where we can plug in any X or Y value and find the opposite. If its initial value, think of initial value as being 0, right? So my initial value is 0. It's 36. So at 0 time, at the very beginning, it's at 36 psi. That's a pretty typical standard tire psi. After 4 minutes here, so keep in mind we're talking about minutes. After 4 minutes, it's at 18 psi. That's pretty rough. Went pretty low. I don't even know if you can drive on 18 psi. So we're going to write the particular equation of the function. So we identified our points. We're going to write 2 equations. So I'm going to use my model y equals a b to the x power. So we're going to plug in 0 and 36 for x and y. So I'm going to say 36 equals a b to the 0 power. And here's my second equation. It's involving this point here. 18 equals ab to the 4th power. All right, so now let's solve. Now I know here anything to the 0 power is just 1, right? So that's 1a. So this is nice, 36 equals a. Once I solve for this a value, I can plug it in here, right? So it's 18 equals 36b to the 4th power. All right, now we have just one variable. We can go ahead and solve for the b. So I'm going to divide by 36 first. So I have 1/2 equals b to the 4th. And then now what do we do next? How do we solve for b? If b is being raised to the 4th power, remember you want to do opposite operation. So my opposite operation is taking the 4th root, and the 4th root of 1/2 is 0.84. So that's your b value. So here's my equation that we're writing. Remember, we're following the model y equals abx, where we want to understand what those a and b values are. So my function is y equals a, we know is 36, and b we know is 0.84. So that's telling me that every minute the tire is decreasing by 84%, right? Or it's decreasing 84% of its original value, which means it's decreasing by 16%, right? That's 100 minus that 84 tells us the decrease rate, 84.84. All right, so it takes you 12 minutes to drive home from school. Find the PSI after 12 minutes. Will you make it home before the pressure drops below 5 psi? So we want to know if x equals 12, is it going to be, will it be less than 5? Will y be less than 5? All right, so we're going to see. We're going to use our function that we created, and we're going to plug in 12 for x because x is time, right? So that's going to be 12 there. And my answer for y is 4.44. So that means, oh, PSI, not minutes. 4.44 PSI. So the question is, if x equals 12, will y be less than 5? Will it drop below 5 PSI? Yes, it will. And you're going to be flat on the side of the road at that time. All right, let's look at the next question. Suppose that the number of bacteria per square millimeter in a culture in your biology lab is increasing exponentially. So that means it's going up, right? It's a growth model. On Tuesday, there are 2,000 bacteria per square millimeter. On Thursday, the number has increased to 4,500. All right, so derive the particular equation. That means that if I didn't write the X and Y table here, but we can think about it. So X and Y, if its initial number is at 2,000, that means at the 0 day, it's 2,000, right? It looks like we're going by days because we started on Tuesday and now we're going to Thursday. Well, on Thursday, that's the second day. If Tuesday is day 0, Wednesday is the first day, and Thursday is the second day, it's going to be 4,500 here. All right, so we're going to derive the particular equation. So our second step there was to plug in the x and y values into our y equals a b to the x value, or to the x power. So we have 2,000 equals a b to the 0. And then we have 4,500 equals a b squared. So I'm going to go back to my first equation. I know b to the 0 is just 1. So a equals 2,000. And we already talked about that a is your initial value anyway. So you could probably skip this step altogether if you wanted to. So 4,500 equals 2,000 b squared. Divide by 2,000. We're going to solve for b now. And that is 2.25. Equals b squared. So how do I solve for b? If b is being squared, the opposite of squaring is taking the square root. You can put a little 2 there, but we don't need it. And the square root of 2.25 is 1.5. All right, so that means that it's increasing by 50%, right? Because it's 1.5, it's 100 plus that 50%. So my equation is y equals my initial value, which is 2,000, plus or times the growth rate, which is 50%, and then x is time. All right, so it says predict the number of bacteria per square millimeter that will be in the culture Tuesday of next week. So how many days is that? So I'm thinking, okay, Tuesday, if Tuesday was 0, Wednesday was 1, Thursday is 2, you can't see what I'm writing, Friday is 3, Saturday is 4, Sunday is 5, Monday is 6, and then the next Tuesday is the 7th day. So that means that when x equals 7, what is y? Right, so we're going to see what the number of bacteria is when x equals 7. So we're going to use our function here, y equals 2,000. 1.5 to the 7th power. So 2,000, 1.5 to the 7th power is a large number. It is 34,171.875. So that's the number of bacteria per square millimeter after 7 days. All right, so predict the time when the culture reaches 10,000 bacteria per square millimeter. So that means what is x when y is 10,000, right? So now we're gonna have to use some of our knowledge of logs for this one. So predict the culture when it reaches 10,000. So I'm gonna use my function that we created in part A, and I'm gonna say 10 1000 equals 2000 times 1.5 to the x power. So I'm first going to isolate, right? I'm going to isolate this value here by dividing by 2000. So we have 5 equals 1.5 to the x power. Now, what do I do when I'm solving for my exponent? I change it to a log. So I'm going to write that little note down. When solving for the exponent, change to a logarithm. Sometimes we get mixed up between here, when I already have the exponent, you take the opposite root of that exponent. And here, when I don't have the exponent, that's when we change it to a log, okay? So when we're solving for the exponent, we change it to a log. So just a reminder, y equals a to the x power, change it to a log by saying log base a of y equals x. All right, so 1.5 is going to be our base, base 1.5 of 5 equals x. So I'm going to get my calculator. Okay, sorry, that calculator wasn't working. All right, so I'm going to control log 1.5 is my base, arrow over to get that 5. And my number is 3.969. So x equals 3.969. So the question again was, predict the time when the culture reaches 10,000 bacteria. So it's saying at almost 4 days, but after 3 days, which would be, go back to our little calendar here. So it's almost at Saturday, right? After Friday. So that would be your answer. And we can kind of check the reasonableness of this answer because I'm looking for 10,000. Well, at 7 days, it's 34,000. We know it's definitely not going to be after 7 days, right? So it's going to be between that Thursday, between 2 and 7. So 3.969 is a reasonable answer. All right, then it says draw the graph of the function. So I'm just going to go to new document. No, I don't want to save. I'm going to go to graph, and all I'm going to do is go back to my original equation there, the 2000 1.5 and to the x power here. Now, for these, notice you can't see it. Why is that? It's because it started at 2000. The graph is too large for this calculator that has the largest thing is at. So you can do one of two things. You can continue to zoom out and notice that it's showing the graph here on the left side. I don't want that graph. I want the graph when it starts at 0. So if it's 2000, I want it to start here at 0. So you may have to adjust your window, and let's see if I can pick something else that'll show me a better one, maybe using Zoom Fit. That might be a better, nope, oh, it's over there. So we may have to put the window where I just want it. So let's see, window settings, how about that one? So I'm going to do my X minimum at -1 and my X max at 10, and then my Y minimum at -1 is fine. And then my Y maximum, because at 7 days, it's 34,000. So let's do it like 35,000. All auto that. Okay, so there, see, when I adjust my own settings, I can get a better visual of what I want to look at, which is really that quadrant number 1, because it's all positive numbers. The time is positive and the bacteria is growing, so it's getting positive as well.